Clara and 3 friends were born on March 11th. Leslie is 5 years younger than Clara, Mike is 2 years younger than Clara, and Thomas is 3 years older than Clara. And instead of asking Clara, hey Clara, how old are you? You happen to know the following information. You don't know how old Clara is, because you never bothered to ask her, but you somehow know that the product of their ages is 61,136 greater than the sum of their ages. And so this is why this is a terrible real-life example, because this would never happen in real life, that you would know this obscure fact about the multiplication of their ages and the sums of their ages while not knowing what their actual ages are. And if you really wanted to know how old Clara is, you could probably ask her. And that would be a lot simpler than solving this math problem. So this is why this example is a great example of a real-life problem gone wrong. But if we take some humor out of it, at least we're going to practice some math skills. And there are some good math skills that we have to practice in here, even though the problem itself is basically useless. So, what are the math skills? Well, first of all, we need to come up with a variable. We're going to say, since we want to figure out how old Clara is, we're going to say she's X years old. Then we can say that Leslie, well, she's 5 years younger, so that'll be X minus 5. Mike is 2 years younger, he's going to be X minus 2. And Thomas is 3 years older. There's going to be X plus 3. So now we've established each of their ages in terms of X. That's going to be an important math skill to be able to do. Second important math skill, can you make an equation of information that's given? What are they given here? The product of their ages is 61,136 greater than their sum. So I'm going to first write this out in words. On one side of my equation, I have product. On the other side of my equation, I have a sum. Which one's bigger? The product. In order to make these equal, does it make sense that I would have to add the 6136 on that side, since the product is bigger? And now that I have it in words, I need to replace this part sum and this part product with actual algebra. How does that actual algebra look like? Well, product is X. That's just multiplying them all together, times X minus 5 times X minus 2 times X plus 3. Sum, if I add these all together, I'm going to get 4x, and adding the numbers together, minus 4, and I still have the 61,136. And we need to solve this equation. And this is going to be a calculator 1 as well. With your graphing calculator, what I'm going to get you to do is type this equation into y1, this equation into y2. In Desmos, you're going to do the same thing, but you'll just go to the top left-hand corner here. X times x minus 5 times x minus 2 times x plus 3. There's our one equation. And in the second one, y equals 4x. I'm going to combine these like terms, 61,132. First of all, you still need to know a little bit about these graphs, because when I graphed it, my red graph appeared, my blue graph is not appearing. Why is that? Because 61,132 is my y-intercept. So again, I could play around with scrolling, or I could go to my tools and say, okay, I'm going to put in 62,000 here. Okay. Then I can see my blue graph. Boy, I barely can see my blue graph. Maybe I even want to go up to 70,000. If you click on one of your graphs, it'll automatically show where they intersect. They intersect at 17,61,200. What I'm really interested in this question is the x value. So how old was Clara? 17, 12, 15, and 20. If this was a test, I would say, since it's a word problem, you should probably write a statement saying each of their ages. But for us right now, we'll just write them that way. So this is an example of a not real life problem. But it does practice our mathematical skills, so it's good in that way. The questions I'll get you to practice for this one are 7 and 8.